In this video, I'd like to talk about the math question of the day for March 9th, 2023. And with this problem, we need to find the exact distance between the two ordered pairs, 0, 5 and 7, 9. So to answer a question like this, you do need to have an understanding of algebra and geometry as well. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through this together. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, when finding the distance between 2 points on the coordinate plane, there are two primary approaches. And really, those two approaches are the same approach, but one is a formula and the other works through this from scratch. But essentially, they come from the same principles. We could use the distance formula. If we have 2 points, x1, y1, and x2, y2, then the distance between these is the square root of the difference between the x values squared plus the difference between the y values squared. But with this formula, you do want to be careful since you don't want to just memorize this. You want to understand where it comes from. And it might be clearer if you square each side, getting rid of that square root. You might notice that this is really just the Pythagorean theorem. So if you want to use the distance formula, that is completely valid. Just make sure you understand where it comes from. However, if you want to look at this from more basic principles, you can start by plotting each of these points. And we can do this point right here, 0, 5 in the pink color. So we go up 5 units right there. And this other point we can do in green at 7, 9. So we go over 7 and then all the way up to 9. And we're looking at the distance between these. Or in other words, we're looking at the length of the line connecting those. We can call that D here. And once we draw this picture, we can construct a right triangle. Since we can drop a line that is parallel to the y-axis or perpendicular to the x-axis going straight down, and we can draw another line coming from this point, but now parallel to that x-axis or perpendicular to the y-axis, and these two lines will meet at a right angle. And since now we have a right triangle, we can use the Pythagorean theorem. We just need to figure out these lengths right here. But notice this has a y value of 9 and this has a y value of 5. So this length here is really just the difference. 9 minus 5, which is 4. And similarly, this has an x value of 7 and this is an x value of 0. So this length here is just the difference, 7 minus 0, which of course is 7. And we can use the Pythagorean theorem. We square 4, we add that to 7 squared, and this is equal to the distance squared. Since, remember, with the Pythagorean theorem, if this is A, this is B, and, well, this is usually called C, then you have that A squared plus B squared is equal to C squared. Where in our case, A and B, these are the legs, and it doesn't matter which is which. This could be A and this could be B, or vice versa. But the hypotenuse, C in this case, in the general case, that is our distance. So this is always going to be equal to the hypotenuse squared, which in this case we call D. Now, actually solving this, we just need to simplify everything. 4 squared, that's 16. 7 squared is 49. Those add together to give us 65. And 65 is equal to D squared. But to get D by itself, we square root both sides of the equation. And we get D is the square root of 65. And notice that we took a square root, but we don't put plus or minus. You can if you want, but you just need to realize that this is a physical length here, so it has to be the positive case. So we found our distance, it's just the square root of 65. But if we want, we can use this formula, since this method can be a little bit tedious. It gives us great insight into what's going on, but if you need to find this quickly, this is not the method you would want to use. And to use this distance formula, we just need to label what x1, y1 and x2, y2 are. We can say that x1, y1, this is really just 0, 5, and x2, y2 is 7, 9, and then we just plug everything in. So x2, which is 7, we subtract x1, which is 0, we square that. Then we do y2 minus y1, so 9 minus 5, we square that, we add those together. And notice it's the exact same equation, just it's already solved for d. So we've already taken a square root of everything. But we get 7 squared plus 4 squared underneath the square root. And 49 plus 16 we know is 65. So we get the exact same answer using the distance formula and using this method where we found this length from basic principles by just drawing a picture. Either method works. It's really your choice which one you want to use here. But like I mentioned, they are really just the same method. It's just that this distance formula already effectively drew this picture and completed the Pythagorean theorem. We just need to plug in the numbers and simplify.